In this next video, we want to look at the planet Mars. Now, Mars is, of course, the fourth planet from the Sun. We have Mercury, Venus, Earth, then Mars. And it's the last of the so-called rocky planets. So it's a planet that's more or less Earth-like in the sense that it is a solid body orbiting the Sun. But there are many ways that it is also very different from the Earth. One of the most obvious differences is its size. Now, when you look at some of the physical properties of Mars, you can see that the radius of Mars is about 3,400 kilometers. That compares to the radius of the Earth, which is about 6,400 kilometers. So the radius is significantly smaller, and also the mass of Mars, which is 6.4 times 10 to the 23, that compares to the compares to the mass of the Earth, which is about 6 times 10 to the 24. So the mass of the Earth is about 10 times bigger than the mass of Mars, and we can see the radius is about half. Now, of course, when you look at the volume of Mars, it works out that Mars is roughly about a third of the size of the Earth. We also see that its density is about almost 4,000 kilograms per meter cubed. That is a lot less than the Earth's density, and so Mars is smaller, it's less dense, and its day, though, however, is 24.6 hours. Of course, on Earth, we know that the day is about 24 hours, so the length of the day on Mars is actually very similar to the length of the day on the Earth. But the size is very different, and it's much, much smaller. Mars does have two moons, Deimos and Phobos, but those moons are very, very small moons. I mean, they're very, very tiny, especially when you compare them to the Earth's moon, which is very large. Now, here we see some images of Mars, and we can see some of these are from Earth-based telescopes, and some of them are from probes that were sent to Mars. But one of the main features here that you can see, even from an Earth-based telescope, is we can see ice caps on the polar regions of Mars. And these ice caps, they grow and they shrink with the seasons. Mars has seasons just like the Earth does. It has a winter and a summer. And during the summer time in the northern hemisphere, these polar ice caps do actually shrink a bit, and they expand in the winter. Now, by the way, these polar ice caps, they're not water ice, at least not entirely. We think that there is actually a ton, not just a ton, there's a bunch of water ice on these polar ice caps, but they're actually covered in what on Earth we call dry ice, which is frozen carbon dioxide. Now, one other feature of Mars that's very interesting is that we know that Mars has really, really strong windstorms. And so that is something that's interesting, that both Earth and Mars have wind-like weather, and that's an important similarity between the two planets, although the windstorms on Mars can be very, very severe. Here we see a picture of Mars showing some of its important surface features. So we can see there's a region here called the Tharsis Bulge, and it's kind of a really large volcanic plateau. It's at a very high elevation. And then another really, really prominent surface feature is the Valles Marineris, which is this gigantic canyon. It's like the Grand Canyon on steroids. It is huge. In fact, it's about 2,000 miles across, 2,000 miles from one end to the other end in length, and it's a couple hundred miles across. And just to give you comparison, if you were to lay this on top of the United States, it would almost stretch from the East Coast to the West Coast. It's a huge, huge canyon. I'm sure that if you were to actually ever be able to go to Mars and you could look from one side to the other, it would be a breathtaking geological feature, just as on Earth the Grand Canyon is. But this is so much bigger than the Grand Canyon. It is a really impressive feature of Mars. Now, here is sort of a relief map showing different elevations. and over here on the right you can see the different colors representing different elevations. This 0 is what we might call sea level, if there were a sea. There is no oceans or seas on Mars. But as you go towards the blue end, that means the elevation is lower. So here, if you see dark blue regions, like here in this region here, that dark blue would tell us that that's about 8 kilometers below the sea level. The whites that we can see in different places up here, like at the Tharsis Bulge that we mentioned, those are places where the elevation is much higher. And this region's, as much as 12 kilometers above the sea level. Also, in this picture, we can see Olympus Mons. I don't know if you can read it there. That says Olympus Mons. That is a really, really large volcano. It's not active anymore. It doesn't erupt anymore, but it is a very, very large volcano. In fact, it's one of the largest volcanoes in the entire solar system. Now, at the time that I'm making this video, NASA actually just sent another probe to the surface of Mars called Perseverance. And you may have seen some of the footage because Perseverance launched a little helicopter probe called Ingenuity. And so we actually have a probe that has a helicopter, like a little drone basically, flying around Mars, doing experiments and investigating the surface of the planet. Now, another thing that you can notice in this picture is that the northern hemisphere is at a much lower elevation than the southern hemisphere. And some evidence suggests that at an earlier time in Mars's history, when Mars was a bit warmer, that there was actually a large ocean of liquid water in the northern hemisphere of Mars. If that's true, that might suggest that at some point in Mars's history, it might have harbored life, like life as we know it. And so, if there was ever life on Mars, did any form of it survive? Is there still life on Mars? Or even if all the life that was once on Mars is extinct now, are there any sort of fossil remnants that show that life once existed there? These are some of the things that these probes are trying to determine. We want to know, was there life ever on Mars? Is there currently life on Mars? And that could mean as little as like bacteria or something. But of course, it's a big deal. If life evolved independently somewhere else in our solar system besides the Earth, that would suggest to us that life is plentiful in the universe and that we'll likely find it in all kinds of places. And to have that proven, that would be very, very exciting. Now, here is a closer image of the Valles Marineris, the giant canyon that I noted in a previous slide. You can see it's about 4,000 kilometers long, so roughly 2,000 miles-ish. It's 7 kilometers deep. It's huge. And we can kind of see here in this inset image, this is a picture of the Grand Canyon on Earth, which shows us a bit of the scale. And here we see another box, and it's magnified, so you can actually see kind of a closer up of some of those surface features. This is the Olympus Mons volcano, which is one of the largest volcanoes in the solar system. What is the largest? You could mean the biggest in terms of volume or area, or the tallest, and so there's some debate on what you would call the largest volcano, but this, however you define a large volcano, this is one of the largest ones in the solar system. It's got a very slow grade of incline though, so it's actually 700 kilometers in diameter from one side to the other at the base, and it raises up 25 kilometers high. So this is an absolutely massive volcano. There are 3 other Martian volcanoes that are slightly smaller. Now, I mentioned that it is believed that at one time Mars may have contained an ocean of liquid water. We're looking for evidence that there might have been liquid water in even more recent times. Now, the problem is that liquid water cannot exist for long on the Martian surface because the air pressure on Mars is so low, any liquid water would evaporate, or depending on where it was on the planet, it's so cold there, the water would either freeze or evaporate. So having liquid water on Mars is probably problematic, but it may be possible for some ice during certain parts of the year on Mars and certain parts of Mars for ice to melt and for water to run. And before it has evaporated, you could have some form of liquid water on Mars. And so we tend to look for evidence of that. Here are some interesting images kind of related to the idea that we're looking for evidence that there could be running water on Mars. We see surface features here that resemble runoff channels on Earth. On the right, we can see a picture of the Louisiana Delta, and here we see an image from Mars. And we can see that there's a lot of similarity between those two pictures. And so could these be the result, could these structures be the result of some sort of water feature? And it would be interesting if that turned out to be the case. Now here we see an actual picture of the surface of Mars that was taken by one of the Viking probes, Viking 1, and we can see that in some ways the surface of Mars looks kind of Earth-like. You can see the ground, you can see the sort of dirt and the rocks and pebbles, and it looks very much like something you might find on Earth. But one thing that is striking is the color. It's so red, and it's not without reason that Mars is sometimes referred to as the red planet. Part of this is because the soil of Mars has a tremendous amount of iron oxide in it, and that on Earth is what we call rust. So basically, there's a lot of rust in the soil on the surface of Mars, and it gives it that rust reddish hue, that reddish color. And so Mars is a very, very reddish place when you're looking at its surface. Here's another image. It's from the Viking 2 probe, and you can see the same sort of features. This is, you know, when you stop and look at these pictures and think about what they really mean, this is the surface of a whole other world. And that is just amazing. Now, here is a photograph of one of the probes, one of the more relatively recent probes. This is the Curiosity rover, which landed on Mars in 2012. And it has been looking for evidence of water on Mars. What's interesting is that this rover was actually designed to explore the surface of Mars for 2 years. So its mission was designed to end in 2014. But it's actually still going on today. It's continuing to move along the surface of Mars, making measurements, and letting us know about the surface of Mars. So it's far exceeded its design expectations, and it has proven a real trooper, and it has been something that has really advanced our scientific knowledge about the planet Mars. Now, here's another shot from one of the Viking probes. Now, the Viking probes, they were sent many years ago. They're much older, but even from the very beginning, we've most been interested in this question of looking for evidence of living organisms or the byproducts of living organisms. And so far, nothing conclusive has been found, but we have only explored a small amount of the surface of the planet, so we are hopeful that maybe someday we will find the evidence for life that we're looking for. And it may turn out that it's just not there. Maybe Mars is a dead planet, but we will continue our exploration until we know for sure. Now, here is our image showing the atmosphere of Mars, and one of the things that is startling is that the atmospheric pressure at the surface, so here would be 0 kilometers, so this would be, what we might call sea level on Earth. On Mars, it's just where they define it. If you go up, say, 50 kilometers, you can come up to this blue curve, and you can go down and you can see what the temperature is. That would be 150 Kelvin, and you can go over and see that the pressure would be about 10 to the minus 5 atmospheres. So that would be very, very low pressure at that elevation, which isn't very surprising. But what is surprising is you go down to zero. If you go down to the ground level, the atmosphere is 0.006. That's 6,000th of an atmosphere. And so that is an incredibly rarefied atmosphere. There is essentially very, very little pressure there at all. If you would be transported to the surface of Mars, you would find that you would get the bends, that the nitrogen in your blood would just boil from being put in that situation. I mean, basically, your lungs would probably burst from the lack of air pressure pushing it in. We can also see that the temperature is 250 Kelvin at the surface. That's about minus 10 degrees in Fahrenheit. And so that very, very cold. Now, during the summer in some parts of Mars, the temperature can go as high as 40, 50, even 60 degrees Fahrenheit for limited times. But on average, Mars is a very, very cold place, and the atmosphere of Mars is not very dense at all, and so that's going to be a problem for any possibility of colonizing Mars in the future for those people that are interested in that sort of thing. Now, we've talked about the runaway greenhouse effect on Venus and how that led to Venus's temperature being insanely high. Mars may be a victim of a runaway greenhouse effect in the opposite direction. Basically, on Mars, as water ice froze, it became more and more reflective. In other words, sunlight that struck the surface of Mars reflected off of the ice and went back into space rather than hanging around long enough to warm the planet up. And so that caused more ice to form, which reflected more light into space and drove the planet to be colder and colder. And eventually, even carbon dioxide would freeze on the surface of Mars. That's how cold it can get. Now, another problem for the atmosphere of Mars, and one of the reasons why it's so thin, is because Mars has very low gravity. Remember, at the very beginning of this presentation, we talked about how much smaller Mars was compared to the Earth, how much less massive it is compared to the Earth. And that means that the gravity of Mars is much weaker than the gravity of Earth. The Earth's gravity is strong enough to strongly hold on to its atmosphere and keep it near the surface of the planet. The weaker gravity of Mars allowed its atmosphere, essentially over millions and millions of years, to escape into space. And this was driven by the fact also that Mars does not have a magnetic field. On the Earth, our magnetic field shields us from all those charged particles coming in from outer space, but Mars doesn't have that protection. And so the atmosphere of Mars is literally stripped away by these charged particles because Mars doesn't have a magnetic shield deflecting them around the planet like Earth does. And so over millions and millions and millions of years, the atmosphere of Mars eroded. If we were able to go back in time into the ancient history of Mars, we may have found that it had a much thicker atmosphere and maybe even that it was warmer and had liquid water on its surface. But now, none of that is true. They're gone. And the last thing that I want to mention about Mars is that it does have 2 moons, but they are very, very small. On the left, you can see an image of the moon Phobos, and it's only 28 kilometers by 20 kilometers. And on the right, you can see Deimos, which is even smaller. Deimos was probably captured from the asteroid belt, and Phobos may have formed later from material ejected from Mars by a meteor strike. But either way, Mars does have those 2 tiny moons, and that is some of the most prominent features of the planet Mars.